my music off. Hey guys, we're going to make a little note card for your test here in 2021. If you already watched the video that was linked, I didn't say that on there. I had it up in a Google Meet instead because we were, anyway, what? So, oh, here we go. So I actually think we'll just put what you can have on your note card on there first. You can't add anything else to it. This is what we're going to go to next. So on your note card, it's just a little index card. We can write about 5 things on it for this test. That the reason is, I mean, if you were in college, you'd probably have to memorize them, but on the AP exam, these don't need to be memorized as part of this chapter. So we're going to go write them down. The first one is that when you integrate tangent, if ever you have to, that's not one that needs to be committed to memory for AP, but it's negative natural log, absolute value of the cosine function, and then obviously plus c. That doesn't need to be committed to memory if you need it. Also, well, okay, that's good enough. When you integrate secant x dx, you get natural log, absolute value, secant x. I even have to pause to remember them because we don't use them enough. They're in my head somewhere, but did you see me kind of pause or something? All right, so there's that one. When you integrate cosecant x dx, also another one that might pop up, but you don't. I'm not saying all of this is going to pop up. This is just stuff you don't need to have committed to memory. It's almost the same as the one above it, except the cofunctions go negative, but then they go cosecant x, cotangent x, and then plus arcaro. So those are the integrals you don't need to have committed to memory. Are we good with those? Then the Pythagorean triples, you should have, not triples, but trig identities. You should have this memorized. What is it? What's 1 plus tangent squared? Hello, kids. Say secant squared x. Secant squared x. There we go. And if ever you get 1 plus cotangent squared, and remember these might pop up in your trig arc length, because if you have 1 plus tangent squared under a root, it can pop a secant out. So just know that that could be fair game, but you don't need to have either one of those memorized. Am I going too fast? No. And then the last one is the formula for surface area of revolution. That is not on the AP test. It would be on a college test, and you probably would memorize it for that, but for you guys can go ahead and use the note card. I don't know if you want to flip it over and write it because it's our only formula, but I'm just going to write it on here. Surface area of revolution, I'm just going to call it S. If you want to tell yourself that that's surface area of revolution, go ahead. And it has a 2 and a pi and an r for the circumference, but the r is actually the height of the function itself. So it's 2 pi f of x, and then it's times the arc length, which is 1 plus the derivative of f quantitatively squared dx. Really, this is 2 pi r arc length. All right, so those are the things you don't have to have committed to memory. Those 5 of you at home, you're going to want to write those on a little sheet of paper. These guys have a little index card, but you can use those on Monday. All right, that's our first thing. Then there are 2 examples in the notes I left till the end, just so we had something, just a little bit of together review. So the first one, go to your note packets, is this guy. Why do you think there's a star by it? What do you think, Priestley?
It's going to be on the test.
Not this one exactly. You know me way better than that.
It's going to be on the AP exam.
No.
I don't know that.
I have it starred because it's similar to one on the test. What I'm telling you with the stars is you will be asked arc length on an algebraic expression. I'm going to tell you that. Okay, it's not this one. But I don't know, are your notes numbered? It's kind of in there. You got to go back a little bit. You'll find it. There's one we didn't do somewhere. You don't have it? I see you guys all leaving. It would have been at the very end. No, let's keep going. very, very, very end of the notes, I think. If it's not, we're going to have to write it somewhere else, or you just leave it copy. Let's put it on the very back. The other one I just saw is in there. We're doing 2 of them in the notes that we never covered. So, for the arc length, this would be on a no calculator. By the way, I might as well write, well, I'll do it when we get to the other review thing. But I'll be very transparent with how many questions are on the test and of what type. I'm telling you, you will have an arc length that goes algebraic. All right, what I mean by that is that this isn't Triggy arc length. It's like X's and numbers. All right, so first of all, that formula needs to be memorized. We're going to integrate from 1 to 3 the square root of 1 plus its derivative squared dx. You will have 4 questions without a calculator, 4 open-ended questions. If you don't have a calculator for this one, what does that immediately tell you should happen? Perfect square better fall out. This better be some chunk of stuff squared. All right? So we need, if it's not, something's wrong with either your, pretty say I said just write it on the back. He's still paging through. There's only a finite number of pages here. Good Lord. He's like, forward, backward, forward, backward. Oh, Lord have mercy. If this wasn't test prep, I'd be really goofy right now because I got a ton of sleep. But test prep, serious. Can you see me fighting it? All right. I know. So let's go take our derivative over here. Test prep, I gotta take seriously. We're going to bring that power out front. It will kill the 3 halves. I'm not saying the one on your test it kills it, but look for reducing. I don't even remember. That's going to kill it. I'm going to go x squared. I'm going to tell you something deadly. Deadly. And you'll probably never recover from it, and you probably won't catch it in relooking and relooking. It happens every year with one like this, that kids say that is the derivative. Times what? 2x. What will happen is then it doesn't end up being a perfect square, but that's a hard mistake to catch because you made it because you spaced out the guts and you probably spaced it out looking at it again. So be careful with that. That is times 2x, the derivative, the chain rule there. Then I need to square it. When you square a product, you do them separately, whether it's super easy algebra or a little bit more complex part of a gigantic formula. I still square the pieces of the product separately. So when I square a square root, it's just going to give me x squared minus 1. It'll pop the 1/2 off. When I square 2x, deadly to call it 2x squared. So you have to be very methodical on your open-ended questions. There's only 4. How many? 4. But that, you bomb one of them, you're out on getting an A because there's only 4. All right? So you really need to have your poop in a group. If you write 2x squared, you're probably not going to catch that. So make sure you're good to go. All right. Because I know I want it as a perfect square, I think I'm going to write 4x to the 4th minus 4x squared. We good with that? What's next in the process? Nice and slow. Add 1. Yeah, I need to do 1 plus my derivative. So I have 4x to the 4th minus 4x squared plus 1. If that is not a perfect square, I've got to really clear my brain and attack it again. Don't even try to go forward. So let's see if it's a perfect square. 4x to the 4th makes me feel really good because it's 2x squared and 2x squared. 1 makes me feel good because it's 1 and 1. Minus and a minus. Minus and a minus. For a second I had a little, because I had a brain fart, but is that good?
Yes.
I would FOIL it, double check it, that looks great. Okay, that's 2x squared minus 1 squared that's going under this root. So I'm going to integrate from 1 to 3, and I'm going to do the square root of 2x squared minus 1 quantitatively squared dx. That's where you go, right? It would be very rare for you to make a mistake and end up with a perfect square, like almost impossible. So you should feel really good about this right now. If you don't get that, I mean, it's not this problem. But if that doesn't happen, don't work for like 20 minutes on it, move on and go back, because you don't want to miss 3 of them. So you try to work it out. So now that's going to pop up. I'm going to integrate 2x squared minus 1 dx. I'm going to go dot, 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 because that goes to Calc 1. You guys know as well as I do, the biggest mistake is the arithmetic. So watch your arithmetic. And is this an FRQ? Is this an actual FRQ? So can you leave a big pumped up answer like 1/3 minus 1/5 plus parentheses 8/9 minus 7? No, don't do that. If it's an FRQ, you can. This is not an FRQ. So 1 point of like 8 of these points will be, I don't know what the exact answer is. I'm going to write that. But, oh, that wouldn't be good. 26/17. All right. So make sure you get one single fraction for that answer. Or you'll get 7 out of 8. Because I'll be like, I want to know that you can do the arithmetic. That one's already. Any questions on that? Yes or no? Nope. Okay. Next up. There's one more we didn't do in here. I think it was something to do with a park. There it is. We didn't do this one, did we? No, let's take a look at this one. The boundary, and this is calculator active, so probably if there's one similar, it's going to land on the multiple choice, because the multiple choice is calculator active, the open-ended is not. All right, so the boundaries of a park is a region bound by the graphs of y equals 3x. There we go, y equals 3x. 8 minus x squared halves. I'm going to actually write that. I don't like that slanted bar, but when I type in Smart Notebook, it doesn't allow me to lock them. But that's my function. Do we know what that thing makes? We should at this point, right, For Delicious? What does the graph of y equals 8 minus x squared halves make? A parabola. It opens down from 0, 8. So you can just do a rough sketch of that, but it's just going to come like this and go like that. Let's pretend I hit it by making a gigantic dot. All right. And the x-axis. Oh, so there's something to be very careful of because it has to be bound by all 3 of those things. Am I in region 1 or region 2? 2. Do you think going into region 1 is deadly? Yeah. Like, almost everything would be wrong. Well, you would have one length correct because it shares this piece. But I'm going to go ahead and shade this in right here. I'm not going to grab my highlighter because my smartboard's been really funky with that. But we're doing this, and I'm going to label these L1 for length 1, L2 for length 2, L3. Remember when it says perimeter to add up all sides, because if it's multiple choice, I can guarantee you College Board, one of them is going to be just the arc length. So for perimeter, let's add up all the sides. Which side would probably be the easiest?
L1.
L1, which requires me to figure out this intersection. 2 ways you could do that. Just sort of guess at it, and if it works, great. So I'm going to let you stare at it and see if you kind of can figure it out without doing any math, per se. 4 would be 8 minus 6. That would give me a 0. 4 in here gives me a 12. So it's not at 4. It's not at 1.
2.
Let's try 2. 8 minus 2. And you're my first out. It is 2. 2, 6. Right? It is going to be a 2. Where those 2 intersect. Oh, I'm sorry. I'm being I'm super sorry. I was finding where these 2 intersect. Sorry. These intersect at 2, 6. You are correct. This is 4, 0. Sorry, I was thinking that intersection, but I asked you for it. You get what I did? All right, not on purpose. Sometimes I do stuff up. That was not on purpose. All right, so L1 is 4. So L1 is 4 plus. What's the next easiest one?
0, 0.
I would do, well, that's a coordinate. I'm adding up these sides. So I've got 4 plus, I would do L2. You actually now, with your math skills, have 3 ways to get L2. You can use geometry and say it's 2 to the right and 6 up, and it's the hypotenuse of a right triangle. A squared plus B squared equals C squared, right? 2 squared plus 6 squared equals L2 squared. 4 plus 36. I'm seeing a root 40, correct? It's calculator active, so I don't really care what that simplifies to. So I'm not going to waste time. Tell me the other two ways throughout your math career, though, without, I just see the geometry of it. I see it as a hypotenuse. So, but what else could you do? Distance formula from algebra, right? You could do the square root of 6 minus 0 squared plus 2 minus 0 squared, 36 plus 4, root 40. What's our third way now? You could do arc length, correct? You could do the integral, right, from 0 to 2 of the derivative, right? What's the derivative? 3 squared, 9, right? Dx. But, and square root it. But we don't need to do that. And 1 plus it. Anyway, you could, but I'm not going to. Next up, our arc length. Okay, that now I do have curvature. I'm going to integrate from where to where? Where to where? What are my limits? There's always a point for limits. Limits from 2 to 4. Yep, you have to have that formula memorized. The square root of 1 plus the derivative of the curvature part. So the derivative of that, 8 goes to 0, right? 2 kills off the 2. Looks like it's a negative x. What am I supposed to do with it? Square it. And this is where if you don't take note that it's calculator active, you don't know how to integrate that. You're stuck under a root, you can't manipulate it, and it's not a perfect square, but you would run that all through your calculator. I know you guys know how to work your calculator, so I don't want to waste your time, so approximately. All right, last up, we are going to go to the front page of your review sheet. This was a very short unit. It only had a few new things in it, but it had the hardest thing from last year in it. Our next unit is much longer. But this one actually, I'm going to go all the way back to that review assignment that you guys have. It's got, the first page is what I want to go through. Do you see this Math 2260, exam number 1? Guess where I got this from? I did. It's some college. It's some college's first exam prep. All right, I didn't make it. I Googled. AP Calc, I didn't say BC, I said Calculus 2. All right, so these questions are kind of prepping you for the open-ended, but let's go back up to here so you know exactly. You will have one question on this topic on your, so here, I want to show you. You have open-ended, you're going to have 4 questions. Right, so that's not very many. Number 3 covers all 3 of these. I will ask you for an area, a volume. I'm not telling you if it's discs or washers or dx or dy. And a cross section. I'm not going to tell you if it's squares. Oopsie daisy. My butt hit the cord. I'm not going to tell you. I got to wait for it to pop up for my. All right. Sorry, guys at home. My butt hit a cord. So this would be like 3A, B, C. So let's make sure you got the area down. All right. And nothing on your note card about these. You just need to have these nailed. I feel good about them, but you won't have a calculator, so make sure you know how to integrate by hand, all that good stuff. Area, we integrate from A to B. Let's, for all of these, throw a fake, my favorite fake function, where F and G intersect like that. All right? So for area, we integrate from A to B. It's all about lengths of rectangles, f of x minus g of x. That's this. With a little bit of depth. That's this. And the integration sweeps it across, covers the whole thing, and gives us the area. Volume by discs and washers. Pi times the integral from A to B, big R squared. Let's make 100% sure you know where big R squared is. So I'm going to go down here. And I'm going to go to, call it y equals -2. Right? Big R is always, there we go, axis to what? Outer edge. Whether you end up having to go up or down, it's axis to outer edge. It's always top minus bottom or left minus right. I'm not going to do both. I'm not teaching this. Just make sure when you go axis to outer edge, know that one of them always is the axis. For this one, it's bottom. But if I put it at y equals 5, my axis would be top, and my bottom would be g. You see what I mean? It's top minus bottom. So for that one, it'd be f minus -2 or f of x plus 2. Are we good? But had it been up here, don't draw it because it'll make a mess out of your picture. But had it been up there, where's my, I think I'm going to go blue just here for a second. Green? Okay. Likes green. My big R would have been axis to the outer edge of the curve, top minus bottom. So if it was like that, big R is 5 minus what? G of x. So one of them's always the axis. It's either the left or the right or the top or the bottom, depending on where it is. Is it all clicking?
Mm-hmm.
Yeah, because last year we were a little rocky on this skill, but are you kind of, is it settling? All right, so minus little r squared. If that's 0, we have the disk. So I'm not going to write that down. If it butts up against the axis, you won't have a little r. What are you going to write for little r? Axis to what? Inner edge, still top minus bottom. For this one, it'd be g minus -2. But if it was this one, it'd be 5 minus f. All right, we're nodding now. That makes me feel good because last year we were like, remember this chapter? You guys were like, did you see me on this? All right, anyway, that's it for those. Did you see me? Cross my eyes. It's going to make me go blind. I might have to take the day off on Monday. All right, anyway. To go to Kevin. Another one. Just kidding, Caden. All right, volume by known cross. He's probably listening. Not right now. Volume by known cross sections. It's still that same thing, right? But our formula is we need the area of a face dx. Now on your FRQs yesterday, one of them gave you a function for this, and it messed some of you up, correct? That's best case scenario. They say that the area of the face can be found by sine of 2x. Great, throw it in, dx, you're done. Right? The geometric ones are when you say, oh, I'm going to build up off of this with my squares. Then I actually have to find the area of a face. They can't tell me what it is. So we've got our squares, which is side squared. We've got our isosceles with the leg across the base, which is 1/2 s squared. You can't write any of that on your note card. You should know it by now, though. We have the isosceles with the hypotenuse across the base. Do you remember what goes in front? 1/4. We have the semicircle. Do you remember what goes on that one? Yes. I ate some pie. And it won't happen, so I'm not going to put it on. Well, I will because I've seen it once on a BC test, but it won't be on mine. Root 3/4 for the equilateral triangle. If it's not a geometric shape like that, they have to specifically give you a function for that. Like they might say the depth of the water is represented by, or whatever. All right, arc length, you've got the formula down, correct? It is integrate from a to b square root 1 plus the derivative squared dx. If you have a calculator, math 9. If you don't, you better get a perfect square under there, or 9 out of 10 times you should get a perfect square. Every once in a while it's u sub. Remember it happened on the worksheet? You're like, oh, this is just u sub. What did it look like? It was like square root of, I think you had one where it's 1 plus 36x. Do you remember that? And you had to let u equal 1 plus 36x, so you're actually doing root u, and you had a 136 fraction. Like, that could happen. Most of the time, though, we are perfect squares or we have a calculator. You also will, oh, by the way, I was going to tell you how many of each of these you have. Arc length, there are 2 of them. Area volume, there's 1. It's number 3, A, B, and C. 1 and 2 are in arc length. Number 4 is on surface area. You do not need to have it memorized, but this one is the most missed every year for the manipulation of it. Because when you do your 2 pi integral from A to B, arc length, and you don't have a calculator, once again, somehow you have to get out from under the root. Either it's a perfect square, or it's U sub, or there were some we've done where it's canceling that's happened. And we're going to talk about that when we get to number 10. All right, on your practice word. Last thing, you'll also have one of the 4 FRQs. What do I mean by that? The from yesterday. Exactly. You don't know which one. All right, so here's your test. 4, open-ended, no calculator, right? 2 arc lengths, an area volume question, and a surface area of revolution. 6 multiple choice with a calculator. They're actual past BC questions that you've never seen before. They're true AP. This is more collegiate. This is true AP. And then 1 what? FRQ. That's your test. Doesn't seem very long, but if you get hung up on one of these, it's going to be deadly. So you're going to have to watch your timing. All right. Next up, you're going to work until either 2 o'clock or somebody gets to number 10. I'm going to explain this to you. So your assignment is 1 through 10 from the College of whoever, I don't know. Google it, Math 2260. Anyway, Calc 1 would have been probably 1260 at that college. If you notice, it says 11 to 13 are extra credit. At that college, you would have had to do them. I put the answers on here, and if you can get those to work, I'll give you extra credit for that. So don't worry about those if your brain's already full doing the other 10. Go ahead and start with number 1. The key is posted, and either if somebody gets to number 10 or it reaches 2 o'clock, we're going to go stop and look at number 10. It's not very long because our chapter wasn't long. And half of it was stuff we did last year, so it's not a long review.
Are these calculator active?
Let me see. We are all no calculator for these, so answers should be exact. Great question. I hope you guys heard that. Am I still recording? I don't know. All calculator active. I mean non-calculator.
Okay.
I hope that recorded. I feel like it was off.
You just kept going. I was like, I don't know. Jeez.
Guys at home who watch this, I know you could hear everything, but I think the window was off a little bit. So I'm going to leave the videos from last year up there. So mainly I would just get the note card from this video.